You start your diesel truck on a freezing morning, look at the dash, see the temperature needle hit the middle a few minutes later, and think you are totally ready to floor it onto the highway. Well, you are actually tearing your engine apart from the inside out, and you do not even realize it. A lot of diesel owners fall into this trap, thinking that once the coolant temperature gauge reads normal, the entire engine is fully warmed up and ready for a heavy load. But that is completely wrong. The coolant gauge only tells you that the antifreeze circulating through the block is hot. Your engine oil, which is the actual lifeblood of your motor, takes significantly longer to reach operating temperature because of its massive thermal mass and thickness. Under normal driving conditions, your oil temperature is lagging behind your coolant temperature by a solid 10 to 15 minutes. So, even if your dashboard says the engine is warm, that thick, cold oil is still struggling to provide the full film protection your engine desperately needs under high stress. You should always drive conservatively for the first 15 to 20 minutes until you are absolutely sure the oil is fully up to temp. If you have a newer rig with a digital oil temperature readout, use it. That is the only real indicator that your motor is ready to make full power. Now, speaking of cold mornings, there is an even bigger mistake people make right in their driveways. Before we tear into exactly what happens inside those cylinders when you let your truck idle, if you are into keeping your ride out of the shop and keeping that hard-earned money in your pocket, hit that subscribe button. All right, so let us talk about the age-old habit of firing up the engine and letting it idle for 10 or 15 minutes while you drink your coffee. You might think you are doing the truck a favor by letting it warm up slowly, but you are actually cutting its lifespan in half. Modern diesel engines are simply not designed to sit there and idle for extended periods. When the engine is cold and just idling, it runs on a very rich fuel mixture. Because the combustion temperatures are easily 400 to 500 degrees Fahrenheit lower than they would be under a normal driving load, all that diesel fuel does not burn off completely. Instead, that excess unburnt raw fuel washes down the cylinder walls, wiping away the critical oil film, and slips right past the piston rings into the oil pan. This is called cylinder wash, and it is terrible for your engine. In just 30 minutes of cold idling, you can dump enough raw fuel into the crankcase to drop your oil viscosity by 20%. You are literally thinning out your oil, destroying its ability to protect moving parts, and causing rapid, premature wear. Studies have actually shown that letting your truck idle for an hour causes the exact same amount of engine wear as driving 30 to 40 miles down the road. On top of that, your transmission, wheel bearings, and differential are still ice cold. When you finally put it in gear and hit the gas, you are shock loading all those cold drivetrain components. The smartest thing you can do is start the engine, wait about 30 to 60 seconds for the oil pressure to stabilize, and then just drive it gently. Driving it at low speeds, under a light load, warms up the engine, the transmission, and the axles all at the same time, evenly and safely. If you live up north where the weather gets ridiculously cold, do yourself a favor and install a block heater or an oil pan heater. That is the right way to handle sub-zero mornings. Another massive issue that stems from excessive idling and short city trips is the clogging of your exhaust gas recirculation system, better known as the EGR valve. This is one of those emissions components that gets a lot of hate, but understanding how it works is key to keeping your rig running right. The EGR takes a portion of your hot exhaust gases, cools them down, and routes them back into your intake manifold to lower combustion temperatures and reduce emissions. The problem is, diesel exhaust is full of soot. When you combine that dry, powdery soot with the oily vapors coming from your positive crankcase ventilation system, it creates a thick, sticky, black sludge that chokes the life out of your engine. When you idle too much or only do short trips around town, the engine never gets hot enough to properly bake off this carbon buildup. Your EGR valve gets stuck open or stuck closed. Your intake manifold diameter slowly shrinks from the sludge buildup, and suddenly you are experiencing rough idles, massive drops in your MPG, and a serious lack of power. A lot of folks think the answer is just ripping the system off completely, but that messes with the factory tuning and can cause huge legal and inspection headaches depending on your state. The real fix is giving that engine a proper workout. Getting out on the highway, getting the exhaust gas temperatures up, and letting the system breathe. Routine cleaning of the EGR valve and the MAP sensor can save you a ton of money and keep that engine breathing cleanly. But even if your air and emission systems are perfectly clean, there is something else that can destroy a modern diesel engine in a matter of seconds. We are about to get into the absolute biggest killer of modern high-pressure fuel systems, a mistake that costs folks thousands of dollars. But real quick, make sure you subscribe so you never miss these critical garage tips. Okay, let us talk about the common rail injection system. Modern diesel systems are engineering marvels. They operate at mind-blowing pressures, easily over 29,000 pounds per square inches, with internal tolerances measured in microns. To give you some perspective, a single strand of human hair is about 70 microns thick. The moving parts inside your fuel injectors and your high-pressure pump rely on tolerances of just 6 to 7 microns. At those microscopic levels, the slightest bit of contamination causes catastrophic accelerated wear. But the absolute worst enemy of your fuel system is not dirt, it is water. Water in your diesel fuel causes instant flash corrosion, cavitation erosion, and completely destroys the microscopic film of lubrication that your pump relies on. Under 29,000 pounds per square inches of pressure, a tiny droplet of water acts exactly like a water jet cutter, slicing right through the hardened steel inside the pump and the injectors. This is known in the shop as wire drawing. Just one bad tank of contaminated fuel can send metal shavings through the entire fuel rail, and you will be looking at a repair bill that could easily hit $6,000. You also have to worry about cold weather. If you leave summer blend fuel in your tank when the temperatures plummet, the wax naturally present in the diesel will crystallize and turn into a gel, completely plugging your fuel filters. You will be stuck on the side of the road with a truck that will not start. If you leave a truck sitting with a half-empty tank for months, condensation builds up inside the tank, and you actually get microbial growth. Yes, bacteria and fungi, known as the diesel bug, will grow in the water-fuel interface, creating a slimy gel that ruins everything. You will know you have fuel issues if you hear metallic knocking from the pump, a highly unstable idle, or if you see milky fuel in the lines. Always buy your fuel from high-volume, busy truck stops. Keep your receipts just in case. Drain your water separator regularly, and use a quality winter anti-gel treatment before the temperatures drop. And please, never put even a drop of gasoline in your diesel tank trying to thin it out for the winter. Gasoline completely strips the lubrication properties away and will shatter your high-pressure pump instantly. Now, because of these strict emissions standards and high-pressure systems, the oil you put in your crankcase is more important than ever. When we talk about oil for a diesel equipped with a diesel particulate filter, or DPF, we are not just talking about viscosity grades like 5W40 or 15W40. The most critical factor is the SAPS rating, which stands for sulfated ash, phosphorus, and sulfur. Modern trucks require low or mid-SAPS oils specifically formulated to protect the after-treatment systems. Here is why it matters. Every engine burns a tiny amount of oil during normal operation. The metal friction modifiers and anti-wear additives in conventional oil do not burn away cleanly. They turn into a solid, incombustible ash. Unlike regular carbon soot, which your truck can burn off during a DPF regeneration cycle, this ash is permanent. It gets trapped inside the tiny honeycomb channels of the DPF, slowly bricking the filter. If you think grabbing any cheap oil off the shelf does not matter, you are making a massive mistake. Using the wrong high ash oil will fill your DPF with permanent ash 3 times faster than normal. Your truck will start trying to regenerate constantly, wasting fuel, and eventually, you will be paying thousands for a replacement filter. Another huge mistake is pushing those extended synthetic oil drain intervals way too far. Just because a bottle says the oil lasts for 20,000 miles does not mean it applies to you. Those extended drain intervals are strictly for ideal conditions, meaning pure highway cruising with perfect fuel and mild weather. If you drive in stop-and-go city traffic, idle a lot, and do tons of cold starts, your oil gets contaminated with soot and unburnt fuel extremely fast. That oxidized oil turns into a thick syrup. leaving sludge deposits that destroy timing chain tensioners, plug up injection system valves, and starve your turbocharger bearings of lubrication. If your timing chain is rattling on a cold start, or your turbo is spitting blue smoke, your oil has completely failed you. Stick to the exact specifications in your owner's manual. Cut those oil change intervals in half if you drive in the city, and never add aftermarket oil treatments that might pump up the ash content and ruin your exhaust system. Speaking of that exhaust system, we have to talk about the system that works right alongside the DPF, and that is the diesel exhaust fluid, or DEF system. This is probably the most hated component on a modern diesel truck, but neglecting it guarantees you will be in limp mode. DEF is essentially just a mixture of urea and deionized water, and it is injected into the exhaust stream to break down dangerous emissions. The problem is, DEF is highly temperamental. If it sits too long, or if it gets exposed to extreme heat or extreme cold, it degrades and crystallizes. Those white, crusty crystals act like concrete, completely clogging the DEF injector nozzle and jamming up the dosing pump. A lot of guys try to save money by buying DEF in bulk and storing it in a hot garage for a year. Do not do that. DEF has a shelf life. If you put stale fluid into your tank, the sensors will throw a code, your check engine light will come on, and your truck will eventually limit your speed to about 5 miles per hour until you take it to the dealership. Keep the DEF tank reasonably full to prevent crystallization inside the tank. Only buy fresh fluid from high turnover stores, and make sure you do not spill it on any wiring connectors because it is highly corrosive and will destroy electrical pins in a matter of days. Finally, let us talk about the temptation of chasing big horsepower numbers. We all love the idea of plugging a tuner into the dash and magically getting an extra 100 horsepower and 300 pound-feet of torque, but cranking up the turbocharger boost limits without the proper supporting hardware is mechanical suicide. Your factory engine is engineered to handle a very specific amount of thermal and physical stress. When you command the turbo to spool up past its engineered limits to cram more air into the engine, you are dramatically multiplying the cylinder pressures. This excessive pressure blows head gaskets right out the side of the block, bends connecting rods, and cracks pistons right down the middle. But the turbocharger itself takes the worst beating. The tiny bearings inside the turbo are spinning at well over 100,000 RPM. When you push the boost limits, you push the compressor wheel out of its efficiency map. This creates intense heat, causes turbo bark or compressor surge, and literally wipes the bearings out, causing the compressor wheel to smash into the housing. If you actually want to build a reliable powerhouse, you cannot just slap a hot tune on a stock truck. You have to invest in proper professional calibration. You need larger intercoolers to lower the intake air temperatures. You need a free-flowing exhaust system to get rid of the back pressure, and you need larger fuel injectors to match the extra air. Upgrading the supporting components is the only way to make big power without leaving pieces of your engine block scattered all over the interstate. Driving a diesel is incredibly rewarding. The low-end torque is unmatched, and they can last practically forever if you treat them like the highly engineered machines they are. It all comes down to patience when warming up, using the exact right fluids, keeping water out of the high-pressure system, and respecting the limits of the factory hardware. Drop a comment down below with what kind of truck or car you are driving right now. Let me know if you are dealing with any weird check engine codes, or tell us what kind of MPG you are seeing lately. Let's talk about it down in the comments. And don't forget to subscribe for more wrenching secrets and garage tips. Catch you on the next one.